What is a literal equation? Basically, it's just an equation that has two or more variables. If I was making the definition myself, I would say it should be two or more different variables. Why would I say that they should be different? Well, we'll get into that in just a second, but let's just take a look at some basic examples that you'll see. These are rather famous examples or common examples that you'll see a lot. Here is a standard form linear equation. It's where the x and y are on the same side of the equation. And a lot of times you'll be asked to rewrite this into a slope-intercept form, but it has one variable here, and here's the second variable. So it has two different variables, okay? So it is a literal equation. Here's the formula for distance. Distance equals the rate times the object's time. So distance equals rate times time. Three different variables. Yep, that's two or more. And here's volume of a prism. So volume equals the length times width times height of an object. So that one actually has four different variables in there. That lines up with our definition perfectly. It's when we get into these situations that people start to wonder why. Um, Most of the time, everybody says, yeah, this should not be a literal equation because it only has the one x. But why is it that this one is considered not a literal equation? Because people say it's got two x's. Well, the reason that I say it should be two or more different variables is because if they had the same type of variable, you can then combine like terms, and 3x plus 4x is 7x. And so as a result, we're left with just one variable, and that's the reason that we say 3x plus 4x equals 10 is not a literal equation. Same thing here, after we slide that 8g out of the way by subtracting 8g from both sides, we're left with 1g equals positive 1. And again, it's the same variable, and after we combine like terms, there's only one variable left. Um, that's the reason it's not a literal equation. So why do we have to be able to rewrite these? It's a difficult skill at first, then it gets a lot easier, but at the very beginning it can cause a lot of frustration. Well, the main thing is this. Sometimes you're going to be asked to do something um, with the formula or an equation over and over and over again. And if the equation is not set up for what you need, like for example, let's look at the distance formula. If we need to be able to discover an object's rate and all we have is the distance and the time, we want to rewrite that equation so we can get the variable that we want all by itself. So we would solve this formula or equation for r in this case. So r equals distance divided by time. Same thing with the prism down here. If you had an object's entire volume with its width and height, but we need its length, you would then go and solve this formula for L, and that would equal the volume divided by width times height. It makes it a lot easier when you're building a spreadsheet to put in the manipulated formula, and basically that's just rewriting it to be what you need it at the moment, and you never know how you're going to have to change it. Um, when you rearrange an equation, especially linear equations in algebra, this is a skill that's going to be needed. They will literally give you a standard form equation like this right here, 8x plus 4y equals 8, and they ask you to go graph it. One of the standards way to do this is to isolate the y all by itself, and it's called the slope-intercept form. You'll actually start getting this type of equation in 8th grade. Um, if we have enough time, certainly I would like to look at how we can manipulate and change a standard form equation to a slope-intercept form equation, so that way by the time you get to algebra, that's one less thing you have to learn. So why do you have to do it? Because there's a lot of things coming up in your mathematical and scientific careers that you're going to need it for. And honestly, I think it reinforces how to solve any type of equation because in order to manipulate it, you're following the same rules. You would say, hey, minus 8x on both sides. And then I want to put it down here. You would be left with 4y equals negative 8x plus 8. And then you would say, well, let's divide this side by 4. And then you would divide this side by 4. And you're left with y equals negative 2x plus 2. And that's how it's done. It's the same properties over and over again.